What is up, amigos? So today we have the aerodynamics of a toaster, and this toaster is pretty nice. It has 6 slots, and it has 3 little levers to control those 6 slots. I'm not really sure how to feel about that, because do you think each slot should have its own lever, or should all slots just have one lever? What do you think is the best situation going on here? Anyway, so we have the aerodynamics here. We have 5 cut planes downstream, and already we can see that this is a very bluff body. You can see that by just how big the wake is and how unsteady it is. So you can see even like the second plane, there is already a lot of unsteadiness, which is a dead giveaway that this is a very bluff object. And I can tell you that the drag coefficient of this toaster is 0.92, so it's very draggy. So now we have a Y plane going through the middle of the toaster, and we can see there is a periodicity to the wake. However, it is not nearly as crisp as what you might expect given how square or rectangular this prism is. But that's most likely due to, first of all, the levers. Secondly, it's a three-dimensional object, which means that there is also going to be some flow periodicity from the edges, from the sides, and also the edges are rounded a little bit. So that means that there's not really as a crisp detachment of the wake as you would get from like a cube, for example. Now we have a Y plane right on the edge of the toaster, and this is really cool because now we're getting this three-dimensional effect occurring where you see some sort of periodicity, and then all of a sudden there's like this warpage of the entire wake, and that's from the other plane, the flow separating in a periodic fashion as well. So there's not a consistent periodicity to it. It's just both of these different wakes separating from different axes melding together and creating this quite strange wake. And I can tell you as well that there is almost no lift being produced with this. The lift is 0.0026 of the coefficient, so that means that it's pretty much 0. It's within the error, and that makes sense because this is a fairly symmetrical object. So now we have a Z-plane right at the base of the toaster. And interestingly, at this plane, the wake is significantly more stable than the Y plane that we just saw, which was on the edge of the toaster, but in the other axis. The possible reason for that is because the base is much squarer, like the edges are much sharper, so that's going to dominate the flow a little bit more. It's going to give a much crisper wake that's being shed. You can see that there's a periodicity to it which stays fairly steady, and that's because of these sharper edges are going to let the flow separate in a much more distinct and consistent point, and that's going to create this nice bluff body flow that we're all familiar with. So now we have a Z plane going through the middle of the toaster, and this toaster now it's near almost the handles where they are. And again, we can see this periodicity, but now it's sort of becoming a little bit sloppy, where there is still that periodicity to it, but it is not nearly as crisp. And that is partly due to the levers, but also partly now we're around the part of the toaster where the edges aren't as crisp. So that means that the other axis, the flow coming from that axis, is going to affect this one a little bit more. There's going to be some sort of an interplay between them. That's why we can see that the flow is not nearly as crisp when it's fluctuating as with the last plane that we just saw. So that's the end of this video. Make sure to like, subscribe, and if you want to get better at CFD yourself, for example, or for theory, check out courses and links, and I'll see you in the next simulation. Peace out, amigos.